Hello, good morning class. Today we will take the brief introduction about the Dennavit and Hartenberg representation. Today in our course Industrial Robotics, today we will going to discuss this topic. This DH representation is basically used to define the position and the orientation of the end effector with reference to the base system, or the position and the orientation of any intermediate coordinate frame or the joint with reference to the base coordinate system. So basically its relative application you will find in defining the instantaneous relative position and the orientation of the instant of individual coordinate frame, or as well as to define the position and the orientation of the end effector at different time intervals. So it will be like how that end effector change its position and the orientation during its processing time when it is following any particular trajectory. So it's a basic diagram that we have to consider, that is representing you the link and the joint parameters. Okay, so here in the figure you will find there are three joints are there. This will be the joint I, this will be the joint I minus 1, this will be the joint I minus 2. So subsequently the joint I is having the axis I, then joint I minus 1 is having the axis I minus 1, then the joint I minus 2 is having the axis I minus 2, and these are their link, rigid links are there, this one, and this is link I minus 1, and this will be the link I minus 2. Okay, so the link and the joint parameters are mainly used to define basically the relative position and the relative orientation of these joints with reference to each other, is with reference to other neighboring links and other neighboring joints. So we'll go to the next slide. So basically its aim is given to why the DH representation is used. Basically it is used to know the position and the orientation of the end effector. What are this part we are discussing today itself, that will be more useful to study the problems related to the 4 degrees of freedom to 6 degree of freedom end effectors, where we want to solve the critical problems in case of the forward kinematics as well as in case of the inverse kinematics. So be careful in this lecture. So basically in this DH representation the main two parts are there. First one is to assign the coordinate system at individual joints. Now after assigning this coordinate system at the individual joint, you should be able to find out what will be its link and the joint parameters. So it is like link means first you have to assign the coordinate system, then after assigning the correct coordinate system you have to find out the link and the joint parameters, and this link and the joint parameters you have to put in the form of table that we will going to discuss further. So first we will discuss about the link parameters. So link parameters and the joint parameters, these are the main DH parameters. First we will discuss about the link parameters. In the link parameters basically there are two units will come. The link parameters is basically used to define the structure of the link. To define the structure of the link means how physically it looks and how its rigid structure looks. and second is a in the digit parameter DH parameters, the second point is a joint parameters. The joint parameters defines the defines you the representation of the relative position of the neighboring links. Defines the representation of the relative position of the neighboring links. This will be cleared in the further part to you. First one, we will take the case of link parameters. In the link parameters, basically the length of the link is one parameter, and second is the angle of twist of the link I, that is denoted as alpha I, and length of the link is represented as AI. Now see in this figure, consider the joint I and axis I and the joint I and the axis I minus 1. Here the length of link is represented as AI. Okay. Now to find out this length of link as AI, we have to consider this axis I and the axis I minus 1. Okay. Axis I means the Zi minus 1 and axis I means the Z suffix I. Now this length of the link is generally represented as the mutual perpendicular distance between this axis I, Zi and the Zi minus 1. Now here you will think there are different cases are there. Let's say the axis Zi and the axis Zi minus 1 both are parallel to each other, then simply the mutual perpendicular distance will remain same across this, all these things, and that will be the link length AI. Now if say these two axes are non-planar, are not lying in one plane, and they are not intersecting, non-planar and non-intersecting, at that time we have to consider the minimum distance exists between the axis Zi and axis Zi minus 1, means that is a mutual perpendicular distance between them, that is a link length I. The second point is a angle of twist of link I. Angle of twist of link I. This will be the link I. How it is being twisted with reference to this axis I minus 1, that is being represented as angle alpha I. Now to see this, basically you have to see this will be the position of the observer, and observer will see along xi axis, along AI, like this. And when the observer will see this, then that observer will have the observation that this xi and axis I minus 1, they are non-planar, they are not lying in one plane. So when the observer will be here, he will see around the AI, and the angle between the axis I minus 1 and axis I, that will be the alpha I. Now how it will be, after this axis I is there, that we will draw a parallel line to this, and that is passing at the joint I minus 1. So we have drawn, these are two parallel lines. So and we have measured the angle from axis I minus 1 to axis I, and that will be the angle alpha I. Now when we are measuring this angle alpha I from axis I minus 1 to axis I, we will see how its sense will be there. If it is a clockwise sense, alpha I will be the -1. If it is a anti-clockwise sense is there, alpha I will be the positive. Okay, and it may have the 0 value also, definitely. Now here one case is there. Simply let's say this axis I means Zi and axis Zi minus 1, let's say both are intersecting. if they are intersecting, definitely the mutual perpendicular distance between them will be 0, means the length of the link AI will be 0. This will be okay. So these are the different cases. Further, now the remaining is the joint parameters. Now what these joint parameters represents you the relative position of the neighboring links. How these neighboring links position is defined, can be defined with reference to the single axis. Okay, so the first point in the joint parameter is offset of the link I. This is the link I, and whose offset we want to define. With reference to what we will going to define it? It will be defined with reference to the axis I. With reference to the axis I of the joint I, we will define the joint offset. We will define the offset of the link I. So it can be defined like it's a distance between the point 1 and 2. So here you will see offset of link I means what? The distance between the point 1 and 2. Point 1 means the intersection between AI and the axis ZI minus 1, and this will be the point 1, and point 2 will be the intersection between the AI minus 1 with ZI minus 1. This will be the point 2. So the distance measured along the axis I minus 1, that will be the distance di, that is the offset of link I, means. And the second parameter is there, that is a joint angle theta I. Now how it will be defined here? For defining the joint angle theta I, okay, for defining the joint angle theta I, you have to take the extension of this AI minus 1 further, and then we have to take the angle measured from AI minus 1 to AI. A parallel line we will draw. This AI will be drawn as a parallel line over here at the intersection point, okay, of AI minus 1 and ZI minus 1. The intersection point is there, and we will draw a parallel line to AI that is being passed through this point number 2, and we will measure the angle from AI minus 1 to the AI. So here the same thing is there. If theta I is measured as in the counterclockwise sense, theta I will be positive, and vice versa. Now here the cases are given. Let's say this joint is a revolute joint. So in that case, theta I will be the variable, means the joint angle will be variable. Let's say, and in this case, the value of di, joint offset of the link I, will become 0 in case of the revolute joint. But when the prismatic joint is there, in that case, the prismatic joint means along this ZI minus 1, some translation is taking place of the link I. Link I is going to translate along the axis ZI minus 1. So in that case, the di will be the variable, and the joint angle will be the 0. Joint angle is not going to change. So here we have discussed about the link parameter and the joint parameters. Now the first step in the DH representation is to assign the correct coordinate system at individual joints. So the basic sequence is given to you here. First you have to assign the Z, then after assigning the Z at the joint, you have to assign the X, and the Y will be the perpendicular cross product of Z and X will be the cross product of Z and X will be the Y axis. Okay, so important is Z and X. Again, accordingly Y will be assigned. Now see the point number 1. Zi is the axis about which the rotation is considered or along which the translation is considered. Always you have to remember this thing. If it's a prismatic joint, Zi will be along that the direction of moment, and if it's a rotary joint, means the axis will be like this, okay. The second case is it's a very basic case. First thing they have defined, if it is a revolute joint, the axis will come like this, and it's a prismatic joint is there, and here some part is there that is going to translate along this direction. So at that time the Zi direction will be like this. Then the point number 2, if Zi minus 1 and Zi are parallel, then in that case what will be the case? The x-axis will be directed from Zi minus 1 to Zi, okay, along their common normal x-axis. So x-axis here will be moved from, will be directed from this Zi minus 1 to Zi. The arrow direction will be like this, and this will be the its link length. It will be its link length, that is a common normal, okay. It is a parallel case of Zi minus 1 and Zi. Now let's say Zi minus 1 and Zi are intersecting. So in that case definitely the link length will be 0, and link length will be 0, but still we have to define the x in the coordinate frame. So x can be selected on either of the two remaining directions. Yes, definitely it will be taken in either of the two remaining directions, but the selection of this x is also you have to consider based on the next joint, whether it is a prismatic joint or whether it is a revolute joint. So based on that only you have to have this, you have to make the selection of the x-axis in the required direction, that will be clear to you in the numericals. See the point number 4. This is the third case. If the axis Zi minus 1 and Zi are along the same straight line, means they are collinear. This is Zi minus 1 and this will be the Zi. So in that case the x1 will be along, here the two planes are there. This plane number 1, it is perpendicular to Zi minus 1 and the Zi, okay. This is a perpendicular plane 1, and this will be the perpendicular plane 2, okay. It is not clear in the slide, but it is a perpendicular plane 2. So the x1 axis will be contained in the plane 1, x2 axis will be contained in the plane 2, okay. So these are will be the probable directions you can consider. And the last one is the direction of the y-axis. Here the direction of the y-axis is there. The direction of y-axis can be taken as like this, means if you define the z, in this case the left one figure, z axis, x axis is like that, then in that case the direction of y-axis will be in the downward direction, and on the right hand side, if the z is defined like that and x is defined relative to z, x is defined relative to z like that, then direction of y will be in the upward direction, okay. So here we have discussed about the basic parameters, link parameter and the joint parameters. In the further lecture we will discuss about how to construct the frames, coordinate frames at the different joint, and how to prepare the tables, and how to obtain the final transformation matrices. Thank you.